Alright, it's time for the solutions for the Master Quiz number 12, which is all about vectors. If you're honors, you're learning about this. So, on this first section here, you're writing down the vector in component form, so you'll see it as a picture, or as vector, or start and end points, and you just need to get the components. So, this little picture here should be right a little bit more, just so it lines up with this point and this point. But anyway, if you're going to get the component form for a vector, you need to get the change in the x from where it starts to where it ends, and the change in y. So this one had to go right 1, 2, 3, 4, and up 1, 2, 3, 4, 5. So that gives you the components of 4, 5. And ta-da, they stand for number 1. And let's see, number 3 here, our initial point is 0, 0. We ended up at negative 3, 8. So the change from 0 to negative 3 comes out to be negative 3. And then the change from 0 to 8 comes out to be 8. Ta-da! There's the component form of that vector. And if you go down to 5, we start out at 5, negative 4, and we end up at 8, negative 3. From 5 to 8 is an additional 3, so the change in x would be 3. And from negative 4 to negative 3 is an increase of 1, so the y component would be 1. And there we go. Moving on to the next side there. Again, this guy should be over just a little bit to the right, just so it lines up. If we start here, and we end up here, that's a change in x of 1, 2, 3, 4, 5, 6. So the x component's going to be 6. And we have to go down 1, 2, 3, 4, 5, 6. So we have to go negative 6. It's going to be down 6. And so that gives me the component form of this vector, 6, negative 6. On number 4, we start out at negative 3, 2. We end up at negative 5, 1. From negative 3 to negative 5 is a decrease of 2 in the x component here. And from 2 to negative 1 is a decrease of 3. So I had to subtract 3 from 2 to get to negative 1. So there's my change in x, change in y. I end up with negative 2, negative 3. And then on 6, we start at 9, 3, we go to 0, negative 4. From 9 to 0 is a change of negative 9. And from 3 to negative 4, that's a change of negative 7. So if you were to take 3 and add negative 7, you'd get negative 4. And there's our component form for all these vectors up top. And that brings us to the next section. We need to, we have some vector things up top, and we're going to have to do some operations on them, getting some magnitudes, adding, subtracting, multiplying by scalar, all that fun stuff. So hold on one moment. Alright, there we go. So I got the vectors already on the screen for me, so so I can refer to them as I go through this one. So on number 7, we're going to do negative 5 times a. Well, a is negative 5, negative 1. You just take negative 5, 8 times by everything that's inside there. You're going to get 25, 5. Ta-da! And on 9, the double vertical line bars means you need to get the magnitude. And to get magnitude, you take your two components, you square them, you add them, and then you square root. So 6 squared is 36, 2 squared is 4. Add that together, you now have the square root of 40, or you can write that as 2 root 10. But yeah, you get this right here. Moving on to 8, we're going to do 3 times a and subtract 2 times c. So I'm going to do 3 times everything that's in here. I'm going to do 2 times everything that's in there. And that's going to give me negative 15, negative 3. I need to subtract. 0 times 2 is 0. And then that's going to give me negative 6 for that one. I need to subtract those. Remember, you subtract the corresponding components. So it's going to be 15 minus, negative 15 minus 0, which is going to be negative 15. And then negative 3 minus negative 6, which is the same thing as negative 3 plus 6, which is going to be 3. So we have negative 15, 3. And then on 10, we need to subtract them first and then get the magnitude. So we're going to take these and just subtract them. Negative 4 minus negative 5, same thing as negative 4 plus 5. That gives me 1. And then we got 6 minus negative 1, so that's the same thing as 6 plus 1, which is 7. And now I have those, I'm going to take those, square them, and then square root. We're going to get, that's just 1, that's 49. 1 plus 49 is 50, so we have the square root of 50, which happens to be the same thing as 5 root 2. So you can have either one of those. On 11, we need to do b plus 4 times v. Well, we need to do 4 times v first. So I'm going to take 4 times by everything that's in v. And that's going to give me, hold on, let me write down b again. Okay, so we got b, and we need to add 4 times v, which is negative 16, 24. Add all the corresponding components. 6 and negative 16 get added, gives you negative 10. 2 plus 24 comes out to be 26. And now we have those added together. And then on 12, we need to get 2 times a, negative 3 times c, and then get the magnitude of both of those, and then add those guys together. So I'm going to do 2 times both of those, negative 3 times both of those, and that's going to give me negative 10, negative 2 for this vector. And then over here, I have 0 and 9. I'm going to get the magnitude of both of those, so I'm going to take negative 10, square it, take negative 2, square it, add those results together, and then square root. That's going to give me 104 square root. And over here, I'm going to take both of those, square them, and then add those results together. Square root that. 0 squared is 0. 9 squared is 81. Add 9. It's going to give me a square root of not 18, but 81. And that happens to be 9 still, so that's plus 9. And if you use a handy-dandy calculator, you can get those things worked out. So square root of 104. Whoops. 104 square root. And then you're going to add 9. Gives you about 19.2. Oh. So there we go. This is the exact answer, the one I see a decimal approximation. And that brings us to our next section, which has a bunch of word problems, and you need to write out a vector that describes what's going on. So Dylan riding back from home goes south at 120 meters per second. So we're going to say south is a vertical component, a y component, and then west is a horizontal component. And I typically say west is negative and south is negative, so that's why those are negative. And if you want to get your velocity, you're going to take both of those numbers. Well, you're going to take the vector and get the magnitude. So that's where you take both the numbers, you square them, you add those squares together, you take the square root of that sum, and that's going to give you approximately... Alright, this one actually comes out to a whole number. It comes out to 150 meters per second. So there you go, 150 meters per second. Elizabeth leaving park, she goes 30 kilometers west and 20 kilometers south. How far she traveled relative to the observer sitting in the park. So if I'm here sitting in the park, and for some reason Elizabeth is walking, going west, south, and apparently the park can see great distances of 30 kilometers and 20 kilometers, but how far she traveled relative to observers sitting in the park. I'm assuming this is just a vector going from where she ended to where she started to where she ended, so that's a negative 30 that way, negative 20 that way. So we have this vector of negative 30 and negative 20. Now just square those. We're getting the magnitude now. So square those numbers. Add those squares, square root that, and that's going to give you. It comes out to be a square root of 1300, which is about 36.06 kilometers. And then the other two word problems that we have here. James rides car from the office, east and south was his velocity relative to his friend waiting at James' office. So he's going east at 60 kilometers, and then south, not kilometers, meters. What is the velocity? Well, we're just going to get these two components. East, I'd say, is positive 60, and then south is negative. And we need to get the magnitude of said vector. So I'm going to take 60, square it, take negative 50, square it, add those sums, and then square root that result, and that's going to give you, so anyway, when we get the sum, you get 6100, square root of that, it's going to give you about 78.10 meters per second. So that's your answer there. And then Lucy rides a bicycle from her house north at 30 meters per second and east at 22 meters per second. What's the velocity relative to her mom waiting at home? Well, I'm just going to skip the whole picture thing. And north is a y component, so I'm going to say that's the 30 component. And then east is positive x component. We get those. If you want to get the velocity, you get the magnitude of that vector, so 22 plus 30 squared, you square root that guy, and that's going to give you, it's going to give you a square root of 1384, which is about 37.20, and that's in meters per second. So there we go, we get that, and that's the whole front side.